Hello, ladies and gentlemen, boys and girls. What's up, people? How are you guys doing? I hope that all of you guys are doing good and taking care of yourself. So, people, how are your IPL days going? I'm pretty sure that majority of you guys here are, hoping that your favorite team wins, and I really do hope that all of your favorite teams win. But then, people, at the same time, you should also be aware that, especially the ones who are going to give your board exams, you have an exam coming up in next 4 months. So please pay attention to a little bit of studies as well. At the same time, watch your IPLs. But yeah, please pay attention to your completing the portions and making sure that you guys are well prepared for your board exams. But with that, all that said, let us get started with today's session. I'm not trying to scare you, but that is a fact, people. My name is Anoop, and this here is going to be the seventh session of light, wherein we're going to be talking about refraction, one of the most important topics of this particular chapter. So without any further delay, let us get right into it, right? So people, in this particular session of refraction, we'll understand what exactly is refraction. Now, the best thing about this particular topic is that you have studied this in your past. You know it already. Now, this is going to be just a refresher course for you guys to, remind yourself what you've learned in the past, and also some of the key points that you have to remember and, write it, jot it down if you have to. Make sure that you have it inside your head. With that said, guys, let us start off this day also with a very interesting quote. And the quote for today is this: action is the foundation key to all success. It's very simple. If you don't do anything, don't expect anything. If you really want to get good marks, you can't just sit and pray all day. You have to take a step to study. You have to put in the effort. You have to write and practice. It's like that about everything. I'll just tell you one thing, people. All these board exams and exams that you have in school, it is not just to give you marks and to test whether you're good enough for the world or not. But these tests and all the things that you do in the school is what is going to help you in life as well. It is just a, it's like a foundation to what you should be facing, or how you have to prepare yourself to face all the things in life. So all the best, and whatever it is that you want to do, I keep saying this every single session, make sure that you put your efforts in that right direction, so that you guys get to where you want to. Anyways, I'm pretty sure that every one of you guys have potential. Every one of you guys have potential. So make sure that you put in the effort. Alright, people. Anyways, with that said, I won't bore you too much with those details. With that said, guys, let's get into refraction. Now, in the sessions ahead, we'll be talking a lot about refraction. So this concept, this particular session is going to be super duper important for you to understand the basic structure of refraction. What exactly is refraction? So in the future, you would be able to easily, understand and relate to everything that I'm going to say. So people, in the last session, numericals on spherical mirrors, I had given you homework. I hope you guys were able to solve all those questions. And yes, people, I'm expecting to know in the comment section below, what was that question that made you think at least a little, or were all the questions Laddu questions? Let me know in the chat, comment section below. Alright, so people, here's the question. A candle is placed 10 centimeters from a convex mirror with a focal length of 10 centimeters. Find the location of the image. You're supposed to find out what is V. So this is the convex mirror that they've given. Sorry, yeah, I just drew a concave mirror. Amazing. Alright, so hold on for 1 second, people. So yes, here you have, it's a concave mirror, convex mirror that you have. The image is placed at 10 centimeters from the mirror, so that's basically on this side, and the focal length of our convex mirror is going to be on behind the mirror, because generally the image is formed behind the mirror, so that's somewhere over there. So yes, that is the focal length. Alright, let me just erase that part out. Yes, people, yes. Alright, so now you're supposed to find out what is V. So how do you do that? 1 by U plus 1 by V, or 1 by V plus 1 by U, how you want to remember it. I don't want to confuse you guys with that, but it's pretty much the same thing. Yeah, anyways, 1 by V plus 1 by U is equal to 1 by F. 1 by V is what you're supposed to find out. 1 by U is going to be minus 10. Why minus 10? Because I told you, remember this, guys, anything onto the left hand side of the mirror is taken as negative, and anything towards the right hand side, positive. So be positive, people. So here it is. Then you have focal length is going to be positive for a convex mirror, so that's what it is. So 1 by V is equal to 1 by 10 plus 1 by 10, which is equal to 2 by 10. That's 5, that'll be 1 by 5. So that is 1 by V. 1 by V is equal to 1 by 5. So what is V? V is equal to 5 centimeters. Dun, 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 dun. That's all. That is the answer for this question. And congratulations to all those guys who gave the right answer. Hats off, people. Keep up the good work. Keep practicing like this. It's important that you do, alright? 4 months, people. Alright. So what exactly is refraction? Let's take a minute break. Alright. Let's take 10 seconds. Relax yourself. And let's get into it. What exactly is refraction? Alright, people. Now, look at this beautiful shape. So you place a straw, or that's basically a glass tube, inside a beaker containing water. And as you bend it, you see that as you just lay it down, you see that the straw, that glass tube, appears a little bent. Like, what is the reason? Is it the water, some sort of magical water that you get from some sort of lake? Or is the glass tube? Probably, right? Or maybe it's a beaker. You never know. Or maybe it's a background. You never know. Alright. Now, why does the straw actually appear bent? We can understand that. Take another look. A simple checkered background. And as you move that beaker, again, the square cube suddenly looks rectangular. Why? Again, is it the water? Is it the background? Is it the beaker? Or is it the person's hand holding the beaker? You never know. Alright, one more example. Look at this. There's a coin placed inside the cup, but you can't see it. But as you pour the water, you're suddenly able to see the coin. Coin magical? Water magical? Cup? Maybe the jug? Alright, anyways guys, no. You guys already know the answer for this one. The reason why all this happens is because of refraction. Let's take the example of the cup containing the coin. Now, initially, you can't see the coin because why? Light always travels in a straight line, rectilinear propagation of light. You know that light always travels in a straight line. So what happens? Light coming from here does not reach your eye because the beaker that is there is blocking the light from getting into your eye. But then, when you start pouring the water inside, now the light is actually traveling between two mediums. There's water from where the light is coming from, and then there's air. Because as the light is traveling from water to air, suddenly what happens is that the light bends, and suddenly you're able to see the coin. This is what is called as refraction. The bending of the ray of light when it's traveling from one medium into another is what is called as refraction. That's all, people. That's how you define refraction. Now, we'll answer why does this happen. But before that, guys, if you think about how you're actually able to see it, see guys, you're able to see the light because after the light bends, what happens? Your eye tries to trace back the step, right? Because your eye always thinks he's a genius. Your eye always thinks he's a genius. He believes everything that he sees and does not, depend on, there's this saying, that seeing is proof. I don't know what, there's some sort of saying, right? That seeing is believing. Yes, seeing is believing. So yeah, so what does your eye do? When your eye sees that ray of light coming from that, like it's getting bent, and your eye sees it. So what does your eye do? Your eye tries to trace back the step, tries to become Sherlock Holmes, and tries to find out where the object is. And apparently, according to your eye, the object is over here. But is that the case? Is that where the coin actually is? No, the coin is at the bottom of the particular cup. But then, for your eye, the object is over there. That there becomes the image. That there becomes the image. So that is how your eye gets deceived by science. Now again, your eye does not know that. Your eye cannot differentiate between the image and the actual object. So it starts to believe that that is where the actual object is. Because once again, your eye is probably very super duper dumb, because he does not know. Anyways, now I'm not talking about your eye. All of our eyes are like that. Alright, now what we're gonna do is we're gonna understand a little bit more about this refraction. Why does it happen? So you see this, guys, refraction actually enables us to see things from a greater distance which you did not even know it existed. You see this, initially you did not know that there was a coin inside that particular cup, but as you start pouring the water, you're able to see it. So refraction is a magical technique that helps you to see things at a further distance. So if you have to define what is refraction, the bending of light ray when it goes from one medium to another, in that case it is from water to air, that is what is called as refraction. That's all. It's a short 2-mark question, people. Aram definition, easy ones. So mention a couple of examples also, and you're good to go. 2 marks, bagged it. All right, now let's talk about why does light do this, right? Why does a ray of light bend? So people, the reason why this happens is because light travels at different medium or different speeds in different medium. In vacuum, the speed of light is 3 lakh kilometer per second. In air, it's 2,99,000 km per second. In ice, it's 2,29,000 km per second. In water, it's 2,25,000 meter per second. And in glass, it's 1,97,000 km per second. Now, it's not to the point. Obviously, the speed of light is not exactly like it's not like a whole number. But then yes, this is how you just round it off and you get this, right? Now, what I want you guys to pay attention on is the speed of light in air and water, alright, because it's going to help you, alright. So speed of light in air is 2,99,000 km per second, and the speed of light in water is 2,25,000 km per second. Remember this, alright. Now, let's get back to an example. Let's say there's a ray of light coming from air, and it's passing through a glass. Simple, very simple condition. That there becomes an incident ray. It's coming and incidenting on the the surface of separation between air and glass. Awesome. Now what will happen? Because it's traveling from one medium to the other, there'll be bending of light. Now why does it happen? Because in air the speed of light is really fast, but then in glass the speed of light is slow. How fast and how slow? The speed of light in air is what? 2,99,000 km per second, but in water it's 2,25,000 km per second. So there's a clear difference between the speed of air in both, speed of light in both air and water, and hence what happens? There is bending of light happening. But then your light is chalak. You know why? Because your light wants to keep the time taken to travel that distance, time taken to be the same. It wants to reduce the time taken to travel from one point to the other. So what does it do? It tries to find a shortcut. It tries to take the shortest path so that it can make up for that slow speed. And here's what happens. Because of that short path, the light changes its path from the original path. See, light was supposed to go this way, but then because the speed of light is actually changing, or it's slowing down when it's traveling from air to glass, your light tries to do what? It tries to reduce the distance covered so that it can try to keep the time taken constant. And so what happens? The light gets refracted and then goes and hits the other surface. So here's the thing, guys. The speed of light is slow in the denser medium. Like in this case, glass is a denser medium and air becomes a rarer medium because the density of glass is definitely more than air. And so what happens? Remember this, guys. When light is traveling from rarer to denser medium, light always travels towards the normal. In other words, it is trying to find the shortest path. So what happens? It tries to bend towards the normal. Normal is what? The imaginary line which is making an angle of 90 degrees to the surface, or it's normal to the surface, or in other words perpendicular to the surface. So you see this, the light gets refracted and it bends towards the normal. Now remember this, people, Speed of light is fast in rarer medium and speed of light is slow in the denser medium. Now, if the light was traveling from glass to air right now, like let's say that it's emerging out. The ray of light is again coming out of the glass slab. This time, what happens? Light is traveling from a denser medium like glass into a rarer medium like air. So what happens? The speed of light increases because it's going from denser to rarer medium. So what does it do? It tries to increase the path, or the path taken by it is longer, so that it can try to keep the path time taken to be constant. As simple as that. This is what light is trying to do. Your light, like I told you, is very chalak. He wants to keep the time taken constant. He doesn't want to do more work or less work. He want to do the same work. So what does he do? In the sense, not literally, but yeah, that's how it is, people. So when light is traveling from denser to rarer medium, light takes the longer path and hence it bends away from the normal, because it has to take a longer path so that it can keep the time taken constant. When light is moving from rarer to denser medium, it tries to move towards the normal because it wants to keep the path taken smaller. It wants to take the shortest distance so that the time taken by the light to go from one place to another is the same. So people, the light ray that is coming out of the glass slab. So you see this, it comes, hits the surface between glass and air now, again gets refracted because it's going from one medium to another, and then emerges out. That ray of light is called as the emergent ray. That ray of light that is coming out of the glass slab is called as the emergent ray. And the thing about the emergent ray is that it is going to be parallel to the incident ray. It's going to be parallel to the incident ray. So there's this, you see this, there's a shift happening. There's this, the light ray, instead of going, instead of taking the original path this way, it has actually moved a little and it's actually parallel. And that distance is what is called as the shift. It's actually shifted from the original path. So in conclusion, people, when light goes from rarer to denser medium, it bends towards the normal, and when light moves from denser to rarer medium, it moves away from the normal. And when light passes through a glass slab, what happens? The emergent ray that comes out, the ray that is coming out of the glass slab, is going to be parallel to the incident ray, and secondly, the ray of light has actually shifted or moved a little from its original path. That's it, people. This here is your very basics of refraction. I hope you guys understood this, because right now we'll be solving some questions. But before we get into the questions, guys, I have a very important notice to give you guys. This here is going to be super duper important, so listen very carefully. So here's the thing, guys. We had actually asked you people, what are the problems that you guys are facing, during this quarantine time, because you guys have a lot of problems that you guys are facing at this point of time, because you're not used to this unconventional way of learning. Majority of you guys are new to the online platform. Your classes are happening on Zoom and on Google Meet and all that, so it's not something that you're used to. So yeah, there are a lot of problems that you guys are facing right now. So what are those problems? These are things that you guys have told us, it's not like we made it up. I'm pretty sure that every one of you guys watching this video would be able to relate to this problem. Firstly, doubts. Sir, my doubts are not getting cleared, sir. I'm learning from so many different platforms and all. So my doubts are not getting cleared, because there are a lot of websites out there, but then it takes about 24 hours to 48 hours. And I really don't want to wait for 48 hours to just give me a one-word answer, right? That's not something that is viable. Secondly, notes, because you are studying from a lot of websites and stuff, but then are you all the time able to download the notes that the teacher has written on the board? Probably not. That's another problem. Thirdly, tests and assignments. How do you test yourself? Because your exams are nearing 4 months to go, so you're scared right now. Majority of you guys are, because you don't have classes and stuff. So how do you test yourself and check whether you are truly prepared for your boards or not? Fourthly, competitive exams, because yes, you guys have been planning to write your KPI and NTSCs and ISOs and NSOs and all that. So how do you train yourself for that? Fifthly, your choice of your schedule, because you're not comfortable studying at 4 o'clock or 3 o'clock in the afternoon, maybe 2 o'clock or 1 o'clock in the afternoon. So what time do you feel comfortable, and whether the teacher is available or not? That is a very big conflict of interest. Lastly, but definitely not the least, choice of your own language. How do you study in a language that you are comfortable in, not that the teacher is comfortable in? Here's the thing, guys. Vedantu's here. We at Vedantu are proud to say this, that we have solved each and every one of these problems. In fact, we have dedicated our lives to make sure that you guys, make your life a little bit more easier, and don't worry so much about it. Here's the thing, guys. In the class, you will not just have one teacher. You will not just have the master teacher to help you clear your doubts and to make you understand the concept. Together with that, you'll also have the class teacher as well. The class teacher would ensure that all your doubts are cleared, making sure that he's able to, walk you out of the class with a clear idea of what the concept was, not with more confusion. You can download all the notes and recordings of every session. So if in case you miss out a class due to some reason, don't worry, people. You can always watch the recording how many ever number of times you want and get your doubts clear. Thirdly, tests and assignments. You have regular tests and assignments to check where you're going wrong and what topics you have to work on. Competitive exams. You'll be trained for all the competitive exams that you guys are applying, right? You have your own schedule. Whatever time you feel like studying, you can choose that time. You have complete control. There's no one to force you study at 2 o'clock. No, you can study if you feel like comfortable. If you're comfortable at 5 o'clock, go ahead. If you're comfortable with 7 o'clock, go ahead. 9 o'clock. Live classes are happening at 24/7. Whenever you feel like studying, you can study that. And finally, guys, you can choose your own language. The sessions are available in both English as well as in Hindi. So if you're someone who's more comfortable in Hindi, you can go with that. If you are someone who's comfortable in English, then you can get the live classes of English as well. So that's it, people. But that's not it. You also get unlimited live classes, whatever, how many of classes you want, you can watch that. You have all crash courses and micro courses, a detailed performance report card on the tests and assignments that you wrote. You'll be getting that as well, and personalized attention from the class teacher. So people, what you will do is very simple. Click on the link that is given in the description below. It will be pinned in the comment section as well. All you have to do is click on that link. What will happen is it will take you to a page which looks pretty much like this. So they'll ask you which grade are you in. So you have choices from 1 to 12th grade. Let's say you're in 10th grade. Once you click on 10th grade, they'll ask you which board do you belong to, CBSE, ICC or Maharashtra. Let's say you're in CBSE. Once you click on CBSE, this is what you're going to get. Everything that I just told you, everything in detail, you'll be finding it over here. So you can pause the video and read it if you want to. What you have to do is click on get subscription. Once you click on get subscription, they'll ask you if you want to go for the 1-month program, 3-month program or the 6-month program. Let's say you want to go for the 1-month program. See how it goes, right? So the base price of that is 4,000 rupees. A lot, right? It's a lot of money. Don't worry, guys. We have got you covered. Don't worry. The base price of that would fall down to 2,699 rupees because you get a primary discount on that. On top of that, if you want to save more money, enter the coupon code AMPRO. Get additional 539 rupees discount, and what you'll be paying for the whole month is just 2,159 rupees 0.2 paise. Now, let's say we're going to the 3-month program. The 3-month program is basically the base price that is 10,000 rupees. But again, people, we know it's a lot. You get a primary discount on that, and what you'll be paying is 6,999. On top of that, if you want to save another 1,000 rupees, probably, yeah. Enter the coupon code AMPRO, get additional 1,400 rupees discount, and what you'll be essentially paying is 5,599 rupees 0.2 paise. Finally, if you want to go for the 6-month program, the base price of that is 16,000 rupees, but we've got you covered. The base price falls down to 11,499. On top of that, if you want a little bit more discount on that, enter the coupon code AMPRO, get additional 2,299 rupees discount, and what you'll be paying is 9,199 rupees for the next 6 months. Now, I'm pretty sure you must be aware, so it's a lot. But think about it, guys. You're getting the best of the best teachers, the best online platform. We're going to be making sure that you guys give your best in your boards, and in the future, if you are ever planning to write your JEE, NEET, whatever it is, we'll be training you for that as well. So try it out. I'm pretty sure you would love it. What you would do is click on the link that is given in the description below and enter the coupon code AMPRO. Simple. Alright, guys, with that said, let's now solve some questions and answers. Now, I want all of you guys watching this video right now to let me know what is the answer in the comment section below. Let me know how was the session. If there's any suggestions, let me know that as well. And also, let me know if you have any doubts and the answers for every question. I want all of you guys to put it down in the comment section below. I want it to be flooded with questions and all sorts of Wonderment. I want to see that, people. With that said, here's your first question. Let me know what is the answer. Wonderment, yeah. Questionable. Alright, here's the first question. As light travels from rarer to a denser medium, it will have increased velocity, decreased wavelength, or both B and C. That is decreased velocity and decreased wavelength. What do you guys think? When light is traveling from a rarer to a denser medium, what does it do? Does the velocity increase? Does the velocity decrease? Does the wavelength decrease? Or both B and C? And the answer to this question, guys, is actually that the velocity decreases. Why does the velocity decrease? Because it's going from a rarer to a denser medium. So what happens? The speed of light slows down. So that that the path of the light changes, and that's what is refraction. So yes, the speed of light actually decreases, so the velocity decreases, and that's why you see the bending of light. Second question. Refraction happens because water holds light rays. Water is fluid, so light bends. Speed of light changes in different mediums, or none of these. What is the reason that refraction happens? Let me know what is the answer in the comment section, people. Here's the question. Water holds light rays. Water is fluid, so light bends. Speed of light changes in different mediums, or none of these. Very simple. Bacha question, Laddu question. The answer is option number C, people. No doubt. Speed of light in different medium is different, and hence this bending of light happens. That is the reason refraction happens. Third question. Light is slower in glass than in water. If light travels to glass, it turns towards the normal, away from the normal, it won't bend at all, or can't say. Here's the thing, guys. Light is slower in glass, which means that the glass here is the denser medium, and water is then the rarer medium. So if light is traveling from water to glass, that is from a rarer medium into a denser medium, what happens to that light ray? Does it bend towards the normal, away from the normal? It won't bend at all, or can't see? And the answer, people, is that it would bend towards the normal, because it's going from rarer medium into a denser, from water to glass. Water here apparently is the rarer medium, and glass here is the denser medium, and hence it will bend towards the normal. Last question, guys. A ray of light is traveling in a direction perpendicular to the boundary of the parallel glass slab. What happens to the ray of light? Does it refract towards the normal? Does it refract away from the normal? It gets refracted along the same path, or does not get refracted at all? So the question is, if a ray of light is perpendicular, so it's basically this is the incident ray. If that is the incident ray, then what happens to the refracted ray, or what happens to the light ray that is traveling from that rarer to denser medium, or from air to glass? What happens to it? Does it refract towards the normal, away from the normal? It refracts along the same path, or does not get refracted? And the answer to this question, guys, is option number D. If the ray of light is hitting exactly at the normal, that is exactly 90 degrees, then it will pass through unaffected. There will be no refraction happening. It will just pass through straight. That's how it is. But yes, you're not done yet. This is your homework for today. Let me know what is the answer for the homework as well in the comment section below. The question is this: an incident ray passes through a rectangular glass slab. The emergent ray is dashed to the incident ray. An incident ray passes through a rectangular glass slab. The emergent ray is dashed to the incident ray. Let me know what is the answer in the comment section below. A very simple question. I hope to see what your answer is. But yeah, let me know whatever I just told you. Let me know how was the session. Let me know if you have any clarification, if you have any suggestions, anything to do to make your lives a little easier. Let me know that in the comment section below, guys. I'll surely take that into consideration. Thank you for joining. Leave a like, subscribe to the channel, be a part of the squad. Thank you for joining. See you in the next one. Take care of yourself. Stay safe. Until the next time we meet. This here is Anoop. Adios, people. Take care. Bye bye.